Good morning, HOD Professor A.K. Chaturvedi sir, my seminar guide Shantilal Meena sir, seminar coordinator D. Sharma sir, faculty members, examiners and my mentors. I am Ankit Soni, pursuing my Bachelor of Technology from University Department of Mechanical Engineering, Rajasthan Technical University, Kota, Rajasthan. Today I am pleased to be here in front of you all to deliver my presentation of seminar topic Solar Distillation, New Trends and Developments. So this is an overview what I will be presenting you in this topic. So first, what is solar distillation? Solar water distillation is the process of using energy from the sunlight to separate fresh water from salts or other contaminants. The untreated water absorbs heat slowly, reaching high temperatures. The heat causes the water to evaporate, cool and condense into vapor, leaving the contaminants behind. Solar stills are used for this purpose. Solar stills can be used for low capacity and self-reliant water supplying systems. Now come to solar distillation techniques. As you know, nature is carrying out the process of water distillation since ages, and water is the most needed substance on the earth for sustenance of life. But due to rapid expansion of population, accelerated industrial growth, and enhanced agriculture production, there is ever-increasing demand for fresh water. So there are many techniques established for conversion of sea and saline water into potable water, which is used for human consumption and their agriculture and industrial purpose. Potable water should not contain dissolved salts more than 550. Now come to the classification of solar distillation is shown in the diagram. Solar distillation is classified into two categories. The first one is passive distillation and the another one is active distillation, which further divided into several categories. There are some other methods for converting brackish water into potable water. So the first is distillation. Saline water is evaporated using thermal energy, and resulting steam is collected and condensed as a final product. And the second one is vapor compression. In vapor compression, here water vapor from boiling water is compressed adiabatically and vapor gets superheated. The superheated vapor is first cooled and to saturation temperature and then condensed at constant pressure. This process is driven by the mechanical energy. And the third one is reverse osmosis. Here saline water is pushed at high pressure through special membranes, allowing their molecules pass selectively and not the dissolved salts. And the last one is electrodialysis. Here a pair of special membranes perpendicular to which there is an electrical field are used and water is passed through them. Water does not pass through the membranes while dissolved salts pass selectively. So what differences we can see here? So in distillation, thermal energy is used, while in vapor compression, reverse osmosis, electrodialysis, etc. some mechanical and electric energies. Now as we discussed in previous slides about distillation, and for distillation solar stills are used. Now question is, what are solar stills? So a solar still is a green energy product that uses the natural energy of the sun to purify the water. The solar still process uses the sun instead of other sources such as fossil fuels to gain the energy needed for purification. There are many types of solar stills that you can see in the slide. Single effect basin solar still, tilted tray solar still, multi-basin step solar still, regeneration inclined step solar still, big type solar still, multiple effect diffusion solar still, chimney type solar still, multi-tray multiple effect solar still, double basin solar still, humidification distiller, multi-stage flash distiller, and solar assisted wide film multi-stage flash distiller. And this is schematic diagram of basin type solar still, which describes the working of a solar still. And these are some components of single effect solar still, like basin, black liner, transparent cover, condensate channel, sealant, and insulation and supply and delivery system. Now come to some materials which we can use in solar stills different parts. In glazing, we use glass or treated plastic, or for liner, materials used are asphalt, matte, black butyl rubber, black polyethylene, etc. In sealant, we use putty, tar, stap, silicon sealant, and for basin tray, we use wood, galvanized iron, steel, aluminium, asbestos, cement, bricks, and concrete, etc. And mainly plastic materials and concrete are used for condensate chamber. Now we will discuss about the requirements of a good solar still, why a good steel is required, a good steel is needed, so that it is easily assembled in the field, be constructed with locally available materials, and be lightweight for ease of handling and transportation, have an effective life of 10 to 20 years, no requirement of an external power sources, can also serve as a rainfall catchment surface, and apart from it, is able to withstand prevailing winds. Materials used should not contaminate the distillate, meet standards, civil and structural engineering standards, and should be low in cost. Come towards dependency of output of solar steel on various parameters. So these are some parameters which are responsible for output of steel. The first one is climatic parameters, in which solar radiation, ambient temperature, wind speed, outside humidity, sky conditions are changed. Another one is design parameter. These are some design parameters: single slope or double slope, glazing material, water depth in basin, bottom, insulation, orientation of steel, inclination of glazing, spacing between water and glazing, type of solar steel that you use. And the third one is operational parameters. And in operational parameters, preheating of water, coloring of water, salinity of water, rate of algae growth, input water supply arrangement are there. So these are some diagrams. This one is for energy transfer in a single effect basin solar steel. You can see the energy transfer in this diagram. And this one for major heat fluxes of a solar steel. After all discussion, we talk about main problems of a solar steel. Sometimes we face the problem low distillate output per unit area, leakage of vapor through joints, and high maintenance. And cost output per unit is very high, are common problems. So we can get the conclusion from all the discuss we did in earlier slide. We can say solar steel output is a strong function of a solar radiation on a horizontal surface. The distillate output increase linearly with the solar insolation for a given ambient temperature, and depth of water in the basin also affects the performance considerably. At lower basin depths, the thermal capacity will be lower, and hence the increase in the water temperature will be large, resulting in higher output. However, it all depends on the insulation of the steel. If there is no insulation, increase in water temperature will also increase the bottom heat loss. These are references of my presentation as mentioned in the slide. Okay, I have completed my topic. If anybody having any query or doubt can ask now, I will be happy to answer.
Yes. What is the major issue with solar distillation?
Solar distillation is suitable for remote, arid and semi-arid areas where drinking water shortage is a major problem and solar radiation is high. The drawbacks to using solar energy for distillation are the high initial cost and the intermittent nature of the sun. Any other query?
Yes. What is the advantage of solar distillation over the other forms of water purification?
So it uses natural and free renewable energy from the sun to purify the water. Water gotten from the solar water distillation process is less corrosive than what you had get from a tap. It is free from chemicals like chlorine or other materials that are existent in the water due to the use of water purifying agents. So, any other questions?
No.
So, I hope you all enjoyed the session. So, thank you.